Okay, right. Okay, testing 1, 2. Is this thing on? I think it's on. Whew. So, I'm a little bit out of breath right now because I ran up the stairs really fast. And I'm not too sure what the sound quality is going to be like on this laptop, so I might put it near my head. Right, bear with. Right, okay, so this little cast, it's going to be for us. Big slap right there. This cast is going to be for all you aspiring scientists out there. Anyone who's got exams coming up, don't stress. Because listen up, right? Here's what this little series is. I've got an exam coming up. It's in 11 days, right? 25th of May. 25th of May, Friday. No, it's not actually. Oh, I just realised I'm going to check my emails because my teacher's meant to be emailing me the new topic. Because it turns out, so it's got 3 topics, but now they've split it into 3 different exams, right? Biology, chemistry, and physics. I thought it was going to be one big exam, and honestly, I like this a bit more. This little system, unless they push the date forward dramatically. So what this is I'm just going to be, doing some revision. Going to be recording it as a podcast, just to help the universe out there. So we've got 41 pages to cover, of varying content per page. Originally, I thought I had 64 pages to cover, but after further investigation, it appears that I only have 41. Therefore, my schedule is way off, because I scheduled to do 64 pages of revision. But that has not come to fruition. Therefore, I'll have to reschedule, and I'll let you all know next episode. But for now, we're just going to make do with what we got. Right. I might time... What? Oh no. Alright. Just had an email off my employers telling me they want me to be flexible during the school holidays. Or they don't know about the album. Yeah, little inside joke there. You won't really get that unless you know about the album. Check it. Healthy Seas coming out 10th of June. Right, okay. Page 1. Cells and microscopy. So alright, all living things are made of cells. Cells are the basic units of life, and all cells come from other cells. So what's that saying is? Right. Microscopes magnify images so it's easy to see cells and their structures more clearly. So right, if you want to look at a cell, you get the microscope, you slap the cell on the little, we call it I don't know what we call it. I think it's called stage. That's where we put the specimen. And you look through the microscope lens. There it is. There's a little cell. The light microscope, right? It's in light microscope. That's what I'm going to be talking about first. Magnification is an important property of microscopes. The magnification is calculated as follows: total magnification equals magnification of eyepiece lens times magnification of objective lens. So, for example, when you're looking for a microscope, you're looking through the eyepiece lens, and you're also looking through the objective lens, and then you look at the specimen. So let's say, for example, an eyepiece lens. It typically has a times 10 magnification. So when you look through the eyepiece lens, you're going to be seeing 10 times bigger. Simple stuff. However, at the end of the microscope is going to be the objective lens, and that, it's mental, right? It times the image by 100. So if you're looking for the eyepiece lens and then you're looking for the objective lens, which is times 100, you times the 10 and the 100 together, then the total magnification is going to be 1000 for that one. pretty simple formula, you know. You just got to figure out, you should understand what the magnification of the eyepiece lens is, and then the objective lens. Not difficult. So the stage that the specimen is going to be on has to be transparent, and it's going to allow light through, because there's going to be a light source at the bottom of the microscope, and that's what's going to illuminate the the specimen, so it can be not looked at in better light. So a cover slip can sometimes be placed just above the specimen, because that ensures that the objective lens of the microscope will not come into contact with the specimen, because that's just disgusting. If you're looking at a cell, you don't want to get that gooey cell on that objective lens, because then it'll be blurry. Stains, I think they're kind of like filters or something that you put across the microscope, and it makes it changes the contrast so you can see the differences. You know, see the features. You know, it helps you distinguish the features between the specimens and stuff. I'm not too sure how that works. They haven't explained it very well, so I don't care. What else is there to cover? I don't know. Okay, moving on to electron microscopes. They were invented in the middle of the 20th century and have a far greater magnification. However, because they use electron waves or something, right, that kills the little specimens that you're looking at, so you can only look at dead specimens using electron microscopes. So there's a little bit of a disadvantage, you know, you win some, you lose some, you know, you get higher magnification rate. But unfortunately, you're going to be looking at dead cells. Oh boy, you don't want that. Right, let's have a look here. Oh, right, this is a little worked example. The photograph shows an electron micrograph part of the cell. Calculate the width of P at its widest part between A and B. So magnification equals size of image divided by size of real. What the hell is this talking about? I don't know. This is just math stuff. This I can do this, you know. Now try this at the bottom of the page. A structure viewed under a light microscope with a magnification of times 400 is measured using a scale in the eyepiece. Each division in the scale is equal to 0.06 mm. The structure measures 7 divisions. Calculate the real length of the structure. Who's got a pen? Where's the paper? Gonna need some paper up in here. I've got a little. Right, okay. Right, so let's figure this out, boys. Okay. So, alright, okay. Magnification of times 400 is measured using a scale in the eyepiece. Okay. Each division. What the hell's a division? What's it talking about? Each division in the scale is equal to 0.6 millimeters. Right then. Let's pause the recording. How'd you pause the recording? Right, turns out it's all basic stuff. Right. So each division, a structure viewed under a light microscope with a magnification of times 400 is measured using a scale in the eyepiece. Each division in the scale is equal to 0.6 millimeters. The structure measures 7 divisions. So right, what you're going to do is use times 0.06 by 7, and using my little calculator here, let's plug this in. So 7 divisions, 7 times 0.06, 0.42. However, we're not done. We are not done yet, boys. So we're now going to divide that by 400 because we've already times the size by 400. So it's times 400 in the magnification, you know. So we're going to divide it by 400 to get the real size. I think. Would it be the other way around? No, it wouldn't. Okay. 0.42, which is a length it shows up as in the microscope. So 0.42 millimeters. I think this is right. Yeah, because why would they even put the times 400? Alright, so divide that by 400, and that equals 0.00105 mm. Now let's check the results at the back of the book to see if we've done well. You don't want to do it. I think there's some answers at the back of the book. Please be right, because otherwise I have to do this again. What the hell? Oh no, I have done it right. Somehow. Oh yeah, I did it right. Whew. Whew, they just rounded it and I got a bit scared. So, you know, what have we learnt today in this little intro topic? We've learnt that I'm sick of microscopes, boys. Moving on to the next page. I'm going to take a bit of sip of my coffee because my throat's a bit dry. I'm going to be looking at purchasing a microphone soon. If you want to pledge to my Patreon to help me get this microphone, it's patreon.com/science. Right, cells. All living organisms are made up of cells. We've already been told this, which share some common features. Right, they all contain DNA, cytoplasm, ribosomes, and have plasma. However, some of these structures differ in prokaryote and eukaryote cells, and we'll learn what that means in a bit. I don't think we will actually, because I understand it still, but I'm just kind of ignoring it. It can't be that important. Oh, so, cells are tiny. It was not realised that living things are made up from cells until Robert Hooke invented the microscope in 1665 and saw cells for the first time in tiny slivers of cork. So remember that. Jot that down in your notepads, boys. Robert Hooke invented the microscope in 1665, and that's when we found out that living things are made of cells. Many years ago. Light microscopes are very limited as to what they can allow us to see inside cells, because the wavelength of light is the limiting factor. So basically, we can't see a lot with light microscopes, they're a bit rubbish. Electron beams have a much shorter wavelength than beams of light and allow much more detail to be seen through an electron microscope. So, you know, we get a closer look at our little specimens. However, and it's a big however, electron microscopes can only view dead materials, because I told you before that the electrons just go pff, pff, they zap the things down there. They kill them. Pretty sad. Structures seen with an electron microscope. Eukaryotic cells contain organelles, which are structures in cells with specialized functions, often bound by a membrane. Only the plasma membrane, nucleus, and nucleolus are visible under the light microscope. only those things. So basically, not a lot, not a lot there. And then we got a huge little diagram, and there's no point in me even trying to explain this on the cast. So I put a little square to remind myself to revise this section off the cast. There's a little question at the bottom though. Make a table listing animal cells, organelles not surrounded by a membrane. Those surrounded by a single membrane, and those. Make a table. Oh, I'm not making a table. You can't make a table on a cast. Right, next page. Prokaryotes. Bacteria are prokaryotes made of a single cell with no membrane-bound organelles. And if you remember from earlier, organelles are structures in cells with specialized functions, but they're not membrane-bound in the bacteria cells, in the prokaryotes. So this structure of a bacteria cell, right? They contain plasmids. These are double-stranded DNA in a circular structure. They often contain additional genes that aid the bacterium's survival. They can contain genes that are antibiotic resistant or toxin-producing genes. There's also a thing called the capsule, which is a layer outside the cell wall. It protects cells from drying out and being engulfed by, for example, white blood cells, and it helps the cells stick to surfaces. I don't know why they'd want to do that, but they do. Ribosome makes the proteins. That's all it does, I think. Nucleoid is a region where single circular length of DNA is folded, and that's important because the DNA carries all the essential information. It doesn't specify what though, so I don't care. Cell wall. It's made of a long chain molecule made up of a sugar and amino acids called peptidoglycan. Right. Cell wall. Yeah, the prokaryotes have a cell wall. Right, gram-negative and gram-positive bacteria. So, what a gram test is, let me just check. Can I not click? Oh no, please don't say I'm still recording. Oh no, it's here, okay. Please be recording. Ooh, we're recording, boys, okay. So a gram staining is a technique in which dye is applied to bacteria, and then if the bacteria retains the dye, so you can look through the microscope, and if the bacteria retains the dye, then the dye will be classified. No, then the bacteria can be classified as gram positive, and if it doesn't retain the dye, then they're gram negative. So, the reason why gram negative bacteria do not retain the gram stain, which is the little dye that's applied, when washed is because their cell wall has an outer layer which absorbs, it sucks in all the little dye. What? Oh, no, got that wrong. Gram-negative bacteria do not retain the gram stain because they have an outer layer which stops the dye from getting into the... which stops it from getting absorbed, because the gram-positive bacteria retain the gram stain because their thick wall... Their thick, the cell wall absorbs the stain, and they don't have an outer wall, so the dye can reach the cell wall. Unlike with the gram-positive bacteria, because that has an outer wall which protects the cell wall, which doesn't absorb the dye. So you might be wondering, why do we need to even differentiate the gram-positive and the gram-negative bacteria? And I'll tell you why. It's because the gram-negative bacteria do not retain the gram stain. Right. Gram-negative bacteria are more resistant to antibiotics than gram-positive bacteria. So, it doesn't really matter about the dye. The dye is just used to differentiate, so we know which one is more resistant. So we know if the bacteria is resistant to antibiotics. The gram-negative ones are more resistant because they have an outer wall, which protects against the cell wall. The capsule, like we said earlier. Yeah, it protects them from the antibody. Now try this. The photograph shows a technician testing a swab from meat of bacteria. For what? So basically, they've got a little swab with like a purple-ish ring around it. Explain the photograph and state what the results show. It shows that you put the dye on, and some of the bacteria has absorbed the gram, which shows that they are gram positive. They have retained the gram stain. This means that they are less resistant to antibiotics because the fact that they've retained it shows that the dye's reached the cell wall and it's not been stopped by an outer wall. You see? Explain why some bacteria stain purple. I've just explained that. Cool. There's some answers in the back. I'm going to check the answers here too because I'm scared. I don't want to spread misinformation on this YouTube channel with billions of subscribers. Literally no one is listening to this. What the hell, man? I'm getting all the answers right. Who wants to at me? If there's teachers watching this right now that go to my school, honestly, just at me. Okay, so plant cells. I've got a lot of squares on this page. This is the last page of today's sesh. This is probably going to go on for the next week or so. I can't imagine it going on past Monday. That's when I'm gonna be doing the recaps in my mind. I'm gonna start focusing on the album after the exam, you know. Dry throat. So I'm sorry. So I've got a lot of blue squares, which means I'm going to revise a lot of this on my own because it's a lot of visual stuff. So this page is called the plant cells. Plants are eukaryotes, but their cells differ from those of other eukaryotes. It doesn't really matter how I pronounce it because I'm not going to be pronouncing it in the exam, am I? Funny stuff. Such as animals. The more complex plant cell. Plant cells include all the structures that are in animal cells. So if you go back, basically contain all the stuff that's in animal cells, which I'm not revised in this book, which I can do other times. But they also contain, as well as all that, they contain chloroplasts, which help with photosynthesis, a vacuole, which stores water and other substances, a tonoplast membrane, which controls movement of molecules into and out of the vacuole, a cell wall for support and protection, a amyloplasts, I don't know, to store starch, and middle lamella to stick cells together, and a plasmodesmata and pits to allow communication between one cell and another. God, the words are so long. I don't know what to do. And there's a little diagram here. And then the rest of this page is just diagrams. So for the next episode, I'm thinking about doing probably 6, because really I've just done this revision in the past like hour, and you could probably tell because it wasn't very good. But tomorrow, you know, I understand the format now that I've got going for me. Tomorrow I'm gonna revise the next, because basically the reason why I stopped here because the next 2 pages link together, and I'm not doing 2 more pages, and I'm not stopping halfway through a little thing. So right, let's have a look. Where does chemistry start? So chemistry starts at page 15. So I'm thinking we've ended. So we'll start page 5 tomorrow, I reckon we'll do pages 5. Yeah, pages 5 to 10 tomorrow. And then the day after that I'll do 11 to 14. And then from Thursday onwards we'll be doing chemistry. We'll have chemistry done by the Sunday. No, we'll have chemistry done on Thursday and Friday. We've got to plough through the chemistry. Bye.